All right, welcome back. So here we are. This will be the first lecture on IoT, the introduction of programming the Internet of Things. So in this lecture itself, we're going to look at a broad overview of IoT and the applications of it. What is IoT? What isn't IoT? We're not going to get into the deep granularity. We're still staying up in the clouds looking down at everything we can see relative to IoT. So with that said, I'll do an intro overview of what the course is going to be to a degree and the expectations along the way. So our overview, when it comes to communication technologies, the hardware size keeps shrinking and shrinking, and the processing capacity is increasing on a daily basis, it seems. Costs or the prices are dropping, and this all leads to more applications being developed. Or when we look at applications, the application of communication technologies are being applied in many ways that we may not have even thought about years ago. So things that we're looking at today, these applications of communication technologies, may seem trivial, but when we look at them today, they are integrated into everything that we're doing. Okay, so we look at this on a larger scale. We need to look at the ease of use that this communication is affording, the connectivity that we have as a result of these communication technologies, the fact that we're able to be more mobile than we were before, and the controls that we have now that otherwise we may not have had. Okay. So essentially, we're dealing with communication networks that transfer information from point A to point B. Now, that point A and point B may be very close to each other. They may be half a world apart. It really doesn't matter, with the exception of the fact that it does take time to get data from point A to point B. So we have hurdles or barriers we may need to cross along the way, but if we look at it in generalities, we're just communicating information, transferring information from point A to point B. Point A and point B may not be directly connected, but they are still connected indirectly, meaning you've got to go through a C or a D to get to B. Just because we have them A, B doesn't necessarily mean they are directly connected. We may have to go through some intermediate point or node to get there. Now, these intermediate points or nodes, as we delve into future modules in the course, it could be something like in a transportation network, one vehicle talking to another vehicle, and depending on which vehicles are close by, that would dictate what the intermediate points or nodes may be. So each node within the network must be able to collect, process, receive, and transmit information. It's all about resource sharing and what we're doing. So on these networks of Internet of Things, which is different than a traditional network. Now, we're dealing with Internet of Things. And the Internet of Things, these IoT devices, need to be able to collect, process, receive, and transmit information. We'll just say data initially, but ultimately it is information. Okay. So these networks could be sensor networks. And when we say sensor network, well, what do you mean a sensor? A sensor could be a variety of things that measures temperature. Well, we could have a thermostat in your house that senses the temperature in a room. That data is then processed through an agent. We'll talk more about that as we proceed, but that data is processed by the agent, and then some action may be taken based on the results of that sensor. It could be something like, let's say, a patient with diabetes that's wanting to make sure that since they do have diabetes, and potentially an extreme case of it, that they don't want to get something called diabetic foot, where they could potentially lose part of their leg or their entire leg as a result of this very harmful disease. Well, we could have a sensor that detects the temperature of that patient's foot in a variety of places on the foot to detect what's taken place. Then the agent determines, does the doctor need to be notified? Is it urgent? Is there a situation at all? So these sensors can be a variety of different types of sensors. We deal with them on I-95. There are sensors that detect vehicles going past a camera, capture an image of the back of the vehicle, detect the license plate, and then from there they process that image of the license plate to send you a toll or bill your account, whatever it may be. So sensors can sense things happening, collect information, they can convert information, process it, communicate with other entities on the network, or an actuator that's associated with the sensor. Sensors, or sensor networks, they're just interconnected sensors where we've got a lot of sensors that are all connected. You could say listening, waiting for something to happen. So these Internet of Things that we deal with, they're pervasive. They're forms of sensor networks that help us to do tasks or acquire insights without actually having to be there. If you think about all these cameras that are reading license plates on I-95 on a daily basis, how many people are replaced as a result of those sensors? We don't have the toll booths. We don't have anybody maintaining a toll booth because the toll booth doesn't exist anymore. So there's a variety of things that have changed to where we don't have to physically be there. We can have an IoT device capture that data for us, and then we can act upon it. So all of these devices, these IoT objects or sensors, are uniquely identifiable. We'll take more into this as we proceed, but for a device to be an IoT device, it needs to have the ability to connect on the network. Now, how it connects on the network? There's a variety of ways to connect on the network. It could be connecting on a cellular network, we'll say cell phones. Let's say a property owner sets up trail cams or cameras on their property to detect trespassers, and it's a 5G device. That's an IoT device. It has an addressable connection to a network. What about the cams that are taking pictures of the license plates on I-95. Addressable on a network, whether it's wired or wireless. It doesn't matter. Addressable device on the network. Now, when we say addressable device, you've been through CEN2212 and you're familiar with TCP/IP, the OSI model, and how devices that we're traditionally used to, these computers on a network, client-server networks, how they communicate. IoT devices are connected to a network and communicate in a very similar, if not in many cases identical manner. We just may have different constraints associated with them. And depending on the module that we're in, we'll look at different perceptions of what's taken place, different instances of IoT in, let's say, transportation and healthcare. Okay. How is the data being transferred? Is it secure? What's taking place? Okay. So the device has to be uniquely identifiable. Think about that. If it's got an IP address, that's a unique value. So an IP address and a MAC address associated with our IoT device, that makes it an IoT device. So you say, what makes something IoT? Self-organizing, pervasive network of objects where each object is uniquely identifiable, and accessible from anywhere and anytime. So we say self-organizing. Well, self-organizing means that the IP addressing and the fact that they can communicate with each other and the packets are being forwarded through the network. Some characteristics of IoT networks: they're flexible. There may be some intelligence there that's helping things to take place. IoT devices do not use a great deal of energy. So we look at them as low energy consumption devices or consumers. Traditionally, we've got large numbers of devices. It's a dynamic environment. We can add and remove devices as needed. We've got heterogeneity and connectivity associated with IoT networks or IoT organizations, if you will. Okay. So when it comes to IoT, where do we see IoT? We see it at home. If I look around my house, what devices do I have that are IoT? I've got an Alexa, I've got televisions, I've got a large saltwater aquarium that has IoT devices associated with it. I've got my thermostat, garage door, so variety just within my home. We talked about examples within transportation, we'll talk about more. Structures, automatic doors, facial recognition for security. Agriculture, we've got devices that detect moisture, chemical composition of water within an area to determine, do we need to apply more nutrients. So agriculture's got a lot of IoT being applied to it. Energy, when it comes to energy, NextEra has got their home office here in Palm Beach County. And NextEra utilizes IoT devices to let it know in its smart grid if the grid is still up, and if not, agent will take action and try to resolve the problem without anybody having to call up and say, hey, I don't have any electricity. When it comes to the environment, we've got sensors that are detecting earthquakes, wind speeds, humidity, moisture. We can predict the weather based on IoT devices. We've got IoT everywhere. So we look at the emerging applications. IoT is just about everywhere we look in some form, and it's becoming more and more prevalent to where we think of it as trivial now. Well, that's just the sensors. Those sensors are quite important. Right? So what are some of the challenges that we're going to have to discuss and deal with when it comes to IoT and IoT devices? Well, privacy and trust. I'll show you some examples of that in subsequent modules. We'll focus on privacy and trust in one module, but in some modules, here's an example of IoT being used and some of the issues that exist. We'll talk about the reliability and resilience of IoT. Who's governing IoT and what standards and policies exist? An entire module on the connectivity standards and policies. The source of energy, how do you power these devices? Now, a lot of times these devices are remote. They don't require a lot of energy, but they do require energy. It could be solar. We could use solar to power them. Maybe wind. How do we go about powering a device that's in the middle of nowhere so that it can communicate? And then how does it communicate? That interoperability. How does it interact with the other nodes on the network? And then data management. It's one of those things. How do we manage what's being obtained, this data that we're collecting from these sensors? How do we manage it? Who manages it? All right. From there, we're going to jump over into the textbook and we're going to look at chapter 1 and the text. So I'll see you over there in chapter 1.